right, let's go ahead and get started. Hello, everyone, and welcome to the Moldex 3D webinar series. My name is April Brown. I'm the applications engineer from the Moldex 3D North American office in Farmington Hills, Michigan. And today we are going to be talking about using DOE to optimize the molding process parameters. So today's topics will include the trial and error method. It's what we use in our operation to solve the problems on the production floor. And then we'll talk about how we can use this trial and error method virtually in simulation. We'll then talk on how we can use DOE to optimize your design, your tooling, and your processing. And then we'll go into a live demo, demonstrating these features, and then review a case study using this DOE method. Right, so we all know the injection molding process can be very complicated. There are multiple variables happening simultaneously, as soon as the material enters the mold. So the material's viscosity may change from shear heating through the runner or the geometry. Its temperature is changing, and during the packing and cooling phase, the part is shrinking and warping onto the mold. And because the mold acts as a constraint, there will be stresses. And these are just a few factors that can be playing a crucial role in your part quality. And some of these common molding challenges might include appearance issues, like stress marks. You might want to understand your well line strength. Is there any air entrapment? And of course, warpage. And as these tolerances become tighter, we want to make sure we are making good parts every time. So this image might look familiar to some of you. I know I've been here multiple times myself. Where you're gathering your team to help troubleshoot a defect. Either if it's by guesswork or running a design of experiment trials at the press. So running a DOE trial at the press can not only be time consuming, but it can be costly in material usage alone.